Hello, algebra students. Mr. Lawrence here with your Chapter 5 review. Remember, the test is Tuesday, right before turkey break. So we're going to go a little comprehensive review for you here. You want to start getting ready, start checking out the pages of your book from page 266 to 269, even 270. Lots of good practice problems in there. Um, with samples. Now, the only types of problems, there are extra problems in there that are not going to be on the test, but the ones that are covered in this video. So first of all, we're going to go domain and range. Remember, the domain are the x values. And so the domain of this set is going to be 0. Remember, I don't list it 3 times. 0 shows up 3 different times, but I just list it once, just like that. The range is going to be 5, 6, and 7. And remember, I write them in order, 5, 6, 7. Okay? Now, I have to determine if this is a function. Well, I like to do it using a map. And there's my domain sign. I'll put a D above that. And here's my range. Look more like an R. And my range goes 5, 6, 7. And I'm going to draw arrows to map. 0 goes to 5, 0 goes to 6, and 0 goes to 7. This, ladies and gentlemen, is not a function because the domain, one member of the domain is going to more than one place. Remember, I told you to think of domain as people and range as places. And so this is like Jacob Roden trying to go to McDonald's, Burger King, and Dairy Queen all at the same time. He can't do that. He's an amazing guy, yes, but unfortunately he can't, or maybe fortunately, can't clone himself and to have 3 Jacobs and show up at all 3 places at the same time. So this is not a function. When a member of the domain repeats to different ranges, you do not have a function. Okay, let's take a look at this blue one over here. The domain would be 1, 2, 3, right? And the range looks like it's going to be 4, 5. All right, well, let's map it out to see if it's a function. My domain would be 1, 2, 3, and then my range would be 4 and 5. And let's see, I've got 1 needs to go to 4, and 2 needs to go to 4, and 3 needs to go to 5. And this is a function because this is like the best buds, Anna and Alexis, both meeting at McDonald's after school one day to get some fries. It is possible for Anna to go to McDonald's and Alexis to go to McDonald's at the same time. This is a function. Okay, this is a function. All right. So it is okay for more than one member of the domain to go to the same range. It is not okay for one domain to have to go to several different ranges. Several meaning 2 or more. All right, talking about graphing, slope-intercept form. Remember y equals mx plus b. B is the y-intercept, m is the slope. You might have an equation that looks like this. I plot my y-intercept of 1, and then my slope is negative 4 over 1 as a fraction. And remember, only one of those is negative. So I'm going to count down 1, 2, 3, 4, and to the right 1. Or I could have counted up 1, 2, 3, 4, and then run 1 in the negative direction. And then I draw my line, 2, 3, 4, 1. There we go. And I'll put a little arrowhead on that. And you do have an arrowhead on the other one. Okay. Now, I could also, if I had a situation like this, say the equation was 2y equals 4x minus, let's change it. Let's make that 6y. 6y, 4x minus 12. Now it's not in slope-intercept form because the y is not alone. So I'm going to divide by 6 and I'll do it on both sides. And when I do it on the right-hand side, I'm actually distributing it. So my new equation becomes y equals 2/3 x. You might be wondering where I got 2/3 from. I simplified 4/6, and 12 over 6 is the same as 2. So I plot -2 on the y-axis. My slope is positive 1, 2, 1, 2, 3, 2/3. 1, 2, 1, 2, 3. Okay, and so when I do that, all right, there we go. There is the second line. Now notice that a line going down to the right has a negative slope, and a line with a positive slope goes up to the right. I think of this one as being uphill, and I think of this one as being downhill. Okay. We also know how to graph from point-slope form, and point-slope form is kind of a strange one. It's a y variable minus a y coordinate equal to the slope times the quantity of the x variable minus the x coordinate, right? The big X and the y are variables. They stay in the equation. The little x and y, the ones with the little subscript ones, are coordinates. So if I had an equation that looked like this, y minus 4 equals 1/3 times the quantity of x plus 2. I know two things about this equation. One, the slope is 1/3 because 1/3 is sitting in nth position. Second, the point is -2, +4. Remember, use the inverse of the numbers. Okay, there's a -4 there, that's a positive. So I'm going to go -2, 1, 2, 3, 4. Okay, and then my slope is going to be rise 1, run 1, 2, 3, rise 1, 1, 2, 3, rise 1, 1, 2, 3. All right, and there we go. That's it. Okay. Let's see here. Let's go down to standard form. Remember, standard form looks like ax plus by equals c. And the a must be greater than 0. Okay? Where a is greater than 0. So if I had something like 4x minus 5y equals 20, graphing from that, would be a great way to use intercepts. Plug 0 in for x. When I plug 0 in for x, I get -5y equals 20. So therefore, y equals -4. 0, -4, 1, 2, 3, 4. By the way, notice how my graphs all have the x and y axes labeled and the origin. You might want to consider doing that. Some of you make mistakes in your graphing because you don't do things like that. Okay, and then I plug 0 in for y. When I plug 0 for y, I get 4x equals 20. And so therefore x equals 5. And I'll put a 5 there, and I'll go 5, 1, 2, 3, 4, 5. And so my line goes through those 2 points. There are my intercepts. And the line will look like that. Okay, that's graphing from standard form. Remember also that if you're in standard form, you can get the slope by taking A, putting it over B, and then changing the sign of the fraction. Okay, and watch. This will be a rise of 1, 2, 3, 4, and a run of 1, 2, 3, 4, 5. And there you go. If I do it again, 1, 2, 3, 4, 1, 2, 3, 4, I just keep hitting the line wherever I go. All right, let's look at a couple other examples here. Writing equations. Now we're usually writing them in slope-intercept form, so y equals mx plus b. A situation like number 3 is super duper easy. I'm actually going to do number 3 first. I have my slope and I have this point. Only this point should be very special to you. This is a y-intercept. How do I know? Because that's 0. The x is 0. I'm on the y-axis. So my equation for number 3 will be y equals the slope times x plus the y-coordinate of the y-intercept. And there you go. Number 3 is done. Okay, to do number 2, I'm actually doing this in reverse order. I have a slope, I have an x, and I have a y. What I don't have is a b. So I'm going to take y equals mx plus b. I'm going to fill in 6 for y, 2/3 for m, 4 for x, and b. And this one's going to end up being a little bit ugly. I made a small mistake, but I'm going to do it anyway because it can work. All right, so I'm going to get 6 equals, and this isn't going to simplify. I'm going to get 8 over 3 when I multiply. Well, 8 over 3 is the same as 2 and 2/3. So I'm going to 2 and 2/3 plus b. Now I'm going to subtract 2 and 2/3, right? And I know some of you get really freaked out over this. Oh my goodness, it's a fraction. All right, well, watch how we do this. First of all, I'm just going to have a b over here on the right-hand side. Okay, so 6 minus 2 would be 4, right? But then I have to take 2/3 of a whole away. So I'm going to be down to 3. And how many thirds make a whole? Well, 3. If I take 2 of those 3 away, I must be left with 1/3. So my equation becomes y equals 2/3 x plus 3 and 1/3. And there you go. It's really not that bad. Okay, number 1 has a little bit of work to it because I do have a couple of points, but I don't have the slope. Well, remember, to get the slope, I'm going to subtract my y's and subtract my x's. So to get my slope, I'm going to do 9 minus 6 over 4 minus 5. That's going to equal 3 over -1, or you can say -3. Now I'm going to, just like I did in problem 2, use y equals mx plus b. I will plug in values for x, y, and m. M is going to have to be -3. Now, x and y, I have a little bit of choice. I could choose x to be 5, and that would force y to be 6. Or I could choose x to be 4, and then y to be 9. I think to keep my numbers smaller, I'm going to make x 4 and y 9, and then I have to solve for b. So when I simplify this, I'm going to get 9 equals -12 plus b. Adding 12 to both sides will give me 21 equals b. My equation, therefore, becomes y equals -3x plus 21. And there we are. Okay, now this video is running a little bit long, but then again, it is a review video. Okay, let's see if we can get these equations into the form they want to be in. Part A, number 1, I want slope-intercept form. Y must be alone. The 3 is attached to the y by multiplication. I'm going to divide by 3. But I'm going to do it on both sides. And when I do that with division or multiplication, that is distributing. So y is going to end up equaling 2/3 x minus 3. And now I'm in slope-intercept form. Looking at example 2 on part A, I've got a plus 6 keeping the y company. Well, I need to subtract 6. Doing it from both sides. I don't do it here as well. If I did it there as well, I'd be subtracting 12 from the right-hand side and only 6 from the left-hand side. Also, I would be trying to combine unlike terms. x terms with non-x terms. So I'm going to subtract 6 from two places, right there and there. Left-hand side will be y, right-hand side will be 4x minus 14. And there you go. All right, trying to get to standard form, I want ax plus by equals c. Which term is in the wrong place? Well, I think the 2x is. So I'm going to subtract 2x from both sides. So I'm going to get negative 2x plus 3y equals 5. But I remember that a has to be greater than 0. And in this case, it's not, so I'll have to multiply through by a negative 1 on both sides. If I do that, I get 2x minus 3y equals negative 5, and I'm in standard form. Okay, number 2. Looks like the y is in the wrong place, so I'm going to subtract 2y from both sides. And when I do that, I get negative 5x minus 2y equals negative 6. Again, I'm not in standard form because a is not positive. So multiply by negative 1. I'll multiply by negative 1. And I'm going to get the equation 5x plus 2y equals positive 6. And we're in standard form. Problem 3, the 6 is messing things up. I'll add 6 to both sides. And that'll give me 4x minus 3y equals 6. And I'm in standard form. All right, last section we're going to cover, and again, you can stop and pause this anytime you want. I've given you this equation right here. I need to know the equation of a line parallel that goes to the point 6,2. And I also want to know the equation of a line perpendicular. Yeah, it does say perpendicular going through the point 6,2. First of all, the slope of this line is 3, right? Now it's just like the problem I did earlier. I'm going to use y equals mx plus b. I'm going to fill in my y, fill in my slope, fill in my x-coordinate, and solve for b. We get 2 equals 18 plus b. b is going to equal negative 16. I know m, I know b. I'm going to get y equals 3x minus 16. You know, one thing I didn't mention was I just assumed you knew parallel lines have the same slope. So if the slope is 3, then the slope of the parallel line is also 3. And that's how I was able to put that right there. Apologize for not mentioning that right away. For the perpendicular one, if my original slope is 3, my perpendicular slope is going to be negative 1/3. Flip the fraction, 3 over 1, and change the sign. But now I'm going to do the same thing I did before. I've got y equals mx plus b. I'm going to put 2 in for y, negative 1/3 in for m. My slope is going to be 6 over 1, and then I'm going to add b. 3 is going to go into 6 2 times. I'm going to get 2 equals negative 2 plus b. Add 2 to both sides. b is going to equal 4. And there you go. That's your review video. Of course, I didn't specifically do things like find the slope when given 2 points, but I did it in other problems. Make sure you're reviewing all that. Monday in class, we'll review some stuff. Get you ready for Tuesday's test. Mr. Lawrence signing off. Good night, everybody.